Nik Bear Brown. Build it with a CLI, then take it apart. To fit a model on a microcontroller, you quantize it. Float 32 down to int8, 4 times smaller and faster. It's the move that makes edge AI possible. But the same 8 bits that leave your weights untouched can quietly destroy an activation tensor, and the model ships broken with no error. The question this video answers: when does int8 mash the signal, and why? Ask for the experiment. In the terminal, Claude E, write quantizedemo.py, int8 quant with a scale and 0 point, and show what the rounding does to a weight tensor spanning -1.5 to 1.5 versus an activation tensor spanning 0.001 to 0.01. Read it before trusting it. The mapping is one line, q equals round of x over scale, plus the 0 point, clipped to the int8 range. Scale is the range divided by 255. The whole story is in that denominator. One scale, calibrated on the wide tensor, applied to the narrow one. Run it. On the left, the weights. The Crimson reconstruction rides right on top of the original, 249 distinct levels, error you'd never notice. On the right, the same scale on the activation sign, and the wave flattens onto 2 levels. Same 8 bits. One tensor is fine, the other is gone. That's a bug, not a law. The fix is to stop sharing one scale. Iterate. Claude. Update quantizedemo.py. Give each tensor its own min and max, per channel, and rerun the collapse metric. Rerun. The activation sign comes back. 255 levels, the curve recovered. Nothing about the tensor changed. Only the scale it was measured against did. So the damage was never int8 itself. It was one scale, set by the widest tensor, crushing the small magnitude range where the signal actually lived. Per channel gives each tensor its own ruler, and the signal survives. Your move. Dump a real activation tensor from your own model and run it through this. See which layers live near the rounding floor. And when your deployed toolchain quantizes, check whether it picked per channel. If it didn't, that's where your accuracy went. Nik Bear Brown. Build it with a CLI, then take it apart. At Nik Bear Brown, nikbearbrown.com.